Those of you who've been with the channel a while may possibly recognise this. It appeared in one video when I did the 40th anniversary of UK FM becoming legal. We plugged it into, what was it, the Fidelity Homebase 3000. I was going to use this when I was operating that night, but it blew a fuse.
Right. I've got a slight hitch with the amplifiers blown up already. I've got to put this one in there.
And we put another fuse in and it did the same, so I parked it up. It's been sitting there for over a year or so now, idle. This wasn't some random eBay purchase. I've had this since about 1990 possibly, and it's been really good. It's always worked. It's got 2 valves in it. You can't see the meter thing here, but it had good output, about 100 watts AM FM. I'd never used it on sideband, but yeah, 100 watts AM FM, and it was good, and I got out all over the place on them. This has got a black front and black cover on it. I think they're meant to be, if you stand this up here and you look at the colour here, I think they're meant to be this sandy colour because the bottom's the same colour as well. So it's got overspray, so I think the case has been sprayed black. Now, on the front, being a valve amplifier, it's got on-off. You've got plate and load, which you tune these to get the maximum coming out. Some people mistakenly think that these two are like a staged power switch, so you can turn the power up and down on the amp. You can't. You have to, as soon as you put this on and you go on to operate, you key up, you have to get this and this one tuned to give you the maximum output on the level here, otherwise it can damage the valves. And then obviously you've got operate and standby, so you flick that, you key up, you talk to someone. When you're not going to be using it for a while, or when you first turn it on to warm up, you put it back in standby. And then you've got your SSB, AM, FM selector switch. It is a bit of a tank. And then on the back here, it's 220 to 240 volts, that's the UK power supply. You've got your antenna one clearly marked, and your transmit. Now it says 52 ohm, obviously we're 50 ohm on CB, but it's always worked well for me. And as it says here, allow 3 to 4 minutes of warm up, adjust plate and load for maximum output on the RF level meter, and in regular operation the meter indicator must be between green and red. I don't know if I can get that to come on. Let me see if I can put a bit more light on. 2 seconds. There we go. So you can see it's like it's a VU meter, like what you used to get in your old stereo system when you was banging out the old bassy tunes. So it goes up to green and red, and it's saying it should be about the 0. And you can get it there. I can get it slightly higher into the red, but it does go up normally around there, as you can see from the little pictures on here. Now, this keeps blowing fuses. So we're going to do some work today and venture inside. Now, a bit of a word of warning here. These amplifiers have about 500 volts or even more inside here, so I'm categorically saying to you, do not venture inside this amplifier, because the voltage is inside here. If you probe the wrong thing, you're a goner. So do not do this at home. There's a couple of massive capacitors in here, and they stay charged for ages, and that's where one lot of voltage is. The other one is around the bottom of the valves. There's another load of voltage in here, so as I say, do not go inside. I have some experience of working on electronics, and this is my unit, so I'm going in, but that's my decision, and I'm not telling you to do this, because basically I want to get this working again. I'm just having a look inside to see if I can see anything obvious. This hasn't been powered up for some time. now, if you can see, there's the inside of the unit. So we've got the two glass big valves there. We've got the two massive capacitors I was on about here, a transformer, a relay, and then, it's a bit hard to see, there's a little printed circuit board on the back here. And it's got a little capacitor on the back there, but I can't see the top of that. And then you've got your plate and load, another capacitor here. That's about it. There isn't really a lot to them. Now the fuse that keeps blowing is on the side here. Now I can't remember if that's blown or not, and I don't, to be honest with you, I don't even know if I've got any more fuses. And obviously you've got your meter with your bulb and things there. So I'm just going to have a quick visual nose about with the camera off, and I'll see if I can see anything obvious that could be causing this fuse to blow. But I can't see anything at the moment. So let me have a look and I'll come back. I can't see anything obvious, but underneath the relay, which is here, there's a row of diodes, 1N4007s. I want to get at those and test them, but it means I've got to take this whole board out, which also means some desoldering as well, so it's quite an involved job to get it out, but I need to get that out because I can't do any work on this unless that's the case. But what that means is I've got to start touching this board. Now I've got a capacitor discharger. I'll do a review video on that at some point in the future for you as well, because it's a very handy piece of kit, as in this case here. In order to use my discharge device, I'll sort of sit that up there. If there's any voltage left in the capacitors, you touch it with these two probes on either terminal. It doesn't matter which polarity. And then the whole time this indicator light is on, ow! Got the cat racing at my arm again. Then you know. Right, let me just get on that. I've turned the light off, I can't see what I'm doing there. So let me go on this lower one here. That's that one. Get on there. Right, there's no charge in that capacitor because the indicator light hasn't come on. If I go on to that one, there's no charge on that one either. So I know now the caps are discharged, there's no power in this unit, so I'm safe to work. But as I say, I'll do a little review video of this just on its own, and then if you want to get one you can. I'll say I'm not affiliated with them, I just brought it because I needed it for another project which I've done a video on, which will be up on the channel at some point, and it worked really well. So I'm just sitting here, I've got some notes on the go of where all the wires and bits and pieces go and how I'm going to take it. So I'm going to disconnect it here so the valves lift out. But then I'm also looking at sort of all the wires, where they connect to. So obviously we've got to put this back together, and where the wires all come from, all the different colours, which bits of the board they go down to. So yeah, just make a few notes, and then if I get lost, I'll take some pictures with a mobile phone, take the torch off, also my written notes as well. So let me just get all that done, and then what I'm going to try and do is get this board out the back and lift it up with the valve still attached, then try and support it on something while we look at, from what I believe the diodes are down underneath here somewhere. I think they're under this relay, so we'll need to get this board out. Right, I've just disconnected this wire. I'm doing this one, and I've lost the spanner now. I brought this little set of spanners the other day. They're like a US Pro set, but they're really good for smaller bolts. I don't know what I've done with the spanner now. I had it in my hand a minute ago. There we go. So these fit on there. That does that, and then you just put a screwdriver in the back and they're off. So let me get this all bolted off and then we'll start desoldering the wires and see if we can get this board out. Right, well, the board is out. I've got all the wire in here. I managed to desolder it. There's a wire down here that goes to the bottom, and then there's two wires here. So once you get all the top ones out, you've got to do them, but they just pull through. So if I move that over there, and then carefully bring the board over, this is what we're after. And I want to be looking on the other side here at the row of diodes which are running up this, you can't really see it actually very well, they're running up the crease of here. That's what we're after, and that's what I want to test, so we need to look at those now. So I'll have to carefully, I'll probably have to desolder these and take these out, I would think. 100 microfarad, 500 volt. Yeah, I'll probably have to take them out. I have also noticed, and I'm being very careful here because I've got the valve still in, there's a broken track here, which I've got to be careful of, so I'm going to have to try and sort that when I put it back. I might put some solder on there quickly just before it falls off. Right, I've quickly dumped some solder across it where it comes around there, and I've managed to save it, but we'll have to put a load of solder along there so when we solder it back it makes a good join. What I have just noticed here is a dodgy joint. I'll get a picture of that. So yeah, not the best joints on the back here, and I haven't touched that one, so yeah, interesting. Right, we'll tidy this board up. At last, my solder wick has turned up in the post. It's a new brand and it's called Chemwick Rosin by Chemtronics. And I've got 15 metres of it, and it's, I think it's 2 metre, or is it 1.5? Can't remember, I'll put something up on the screen later. But it works. So if you're looking for a replacement solder wick for your solder mop stuff that you can't get, you know, service solder stuff anymore, I highly recommend that because that actually works. You can see sort of on the end it's really wicking the solder, which is great, so that's a plus. So what I've done, I've used this Tupperware container I found in the cupboard, but don't tell anyone, and then I've carefully put this across and laid it in there so the valves are not touching. I can push down a bit on top of here and do the desoldering. And at this point here, I've desoldered one of the 1N4007, I believe they are, yep, diodes. And I'm going to desolder all of them and test them. I've also got that dodgy solder joint here, which when we desolder we can redo it. But I want to test the valves and double check they're all okay. And not test the valves, test the diodes. And you can get readings from components when they're in circuit, but it's always best to either lift one leg and test it so it's not in circuit, or completely desolder the thing and take it out. And as these are diodes, I want to check all round them as well and go over them with the eye loop and make sure that, although from the top they look okay, they haven't been overvolted and like got a crack in them on the underneath, which you wouldn't be able to see. Your test would probably show it up, but I'd just like to be thorough on this. So let me get the meter set up, we'll test this diode, I'll show you how to test it, and we'll find out whether this first one is any good. So what we do to test the diode is On the diode, as shown up on the screen now, you can see there's a band, silver band or white band or black band or whatever. That indicates the negative end, the cathode. The other end is the anode. So if you put your black probe on the negative leg and your, oh, I don't think you can see it there, I'll have to put it on its side, and you put your, let's put it there, your red probe on the anode, you should get a reading. We do. We've got about 0.586. So 0.57, 0.58 for a diode, these 1N ones, is about correct. Then if you change your probes around, leave the component where it is, and you put the positive on the banded end and the negative on what was the positive end, you shouldn't get a reading. And we haven't. If we got a reading, it means the diode is shot. Now on the meter itself, there's the symbol here for diode test. It's a triangle with a vertical bar. That's what you set it to, and I'm in DC as well. And it's as simple as that. So that diode is good. So I won't show on camera, but I'll quickly desolder the other three diodes, and we'll test those and also give them a visual inspection. Well, I seem to have a difference. Initially, when I touch this one, I get 1698. It flashes on the screen, then it goes down to 587. This one, you touch it straight on to 587, no different figure. This one starts about 690 and goes down to 587. And this one here goes to 587. So, as diodes, if I flip them around the other way, I'm not getting any problems. But that initial blip, I don't know. I'd rather, while I'm in here, because of the aggro it took me to get this thing apart, these diodes are cheap. So I think what I'm going to do is I'm going to order 4 new diodes, and we chuck 4 new diodes in, so we know they're good. The thing I have noticed on here, it does look to me like the top of these capacitors have shrunk back. So I'm definitely going to replace those two. And I've just noticed there's another diode down the side there. We'll have that out. And last night on eBay, this is a 2N1711 transistor, the silver can here. I found 3 of those on there for £3.20, some new old stock. So I've snapped them up. So I'm going to definitely have some spares of those while I see them. Then we've got a big, probably 1 watt, 2 watt resistor here as well. I want to desolder that and measure that as well. But yeah, first thing is we're definitely replacing these diodes. I'm not sure if I can show that, but down in here, behind that capacitor against the thing, there is another diode. This time it's a 1N4004. And when you get, low and behold, to the back of it, it's just got the leg poked through the hole. There's a tiny bit of solder on the far side here. There's a picture of it up on the screen now of the condition of that solder joint, which, as I'm sure you'll agree, is pretty poor. I've just seen another dodgy joint as well. God, there's loads of them on here. That's actually a really bad one. It looks like it's the capacitor joint. Hold on a minute. No, it's actually this joint here, but looking at that, it looks like it's just a hole through the board. It's just got a bit of solder splashed into it. So this is where the capacitor is, underneath this resistor here, which also looks like capacitor here, which also looks like it's got a certain amount of shrink back on it. So we'll definitely have that out of there. So I'm just going to quickly desolder this one. We'll drop that one out. We'll check that diode.